Good afternoon. So we start this lesson, Math 4, and then it starts with Chapter 1, which is somehow mathematics proofs and things like that. This is omitted from Math 4. Okay, some part of it has moved to Math 5. So the starting point for our discussion is the second chapter, which is Trigonometry. Okay, so the first chapter is actually removed from this course. And then most of the trigonometry, I don't know, I haven't been your teacher before, so except you. Yeah. But then, so I will start more or less from scratch, okay, and then maybe these two sessions. So my point is to teach one session more or less from the beginning to the end, and give you the second session to practice on your own and come back to me if you have some questions. The bad point about this Origo is that I couldn't find any solution manual written by the authors, but we were able to manage it in the technique group so that we can find something. I think the solutions there that I have uploaded on Google Classroom already for Chapter 2 are reasonably good. Okay, but I haven't reviewed all of them. So if you get suspicious to some of the solutions, please just come and ask to make sure that everything written there is correct. But that's the bad point about this. Math 1, 2C, 1C, 2C, 3C, we have the solution manual written by the authors, but I couldn't manage to find any solution manual. If you have some extra information, please update me so that we can ask the school to buy that for us as well. Okay, anyway, so we start with Chapter 2. The first part of it is trigonometry in right angle triangles. Yes. And then hopefully this lesson will be finalized by the second session, and then we go to the new topic. So mainly trigonometry in a right angle triangle is actually the starting point of trigonometry, but I don't know how much you remember from Math 3C that you were learning trigonometry in the unit circle. So that is the main part of things. And as I told you, I will not consider that you remember those things, so I will start from scratch, but might be I go a little bit faster in those topics which are related to Math 3C. But I by no means, I start complete from scratch, everything I will explain. Okay, so let us start with trigonometry in a right angle triangle. So I have a right angle triangle. So as you know, I have a triangle. So one of the angles is 90 degrees. So let me call this, we can call this A. And then let me call this B. And then let me call this C. So I want to talk about sine, cosine, and tangent of only the acute angles in this triangle. Acute angles are the angles between 0 degrees and 90 degrees. So theta, an angle which is strictly larger than 0 degrees and strictly less than 90 degrees, is called an acute angle. Yes. So you know that in every right angle triangle we have two of those angles. One of them is B, for example, in this picture, and the other one is C. We can talk about sine, cosine, and tangent of B. We can also talk about sine, cosine, and tangent of C. But in this context, we cannot talk about sine and cosine of and tangent of A, because A is not an acute angle. And it doesn't mean that we cannot talk about sine of 90 degrees, we cannot talk about cosine, because we can. If you take your calculator and punch sine of 90 degrees, at the end you will get a number 1, for example, in this case. So it means it is meaningful, but not in this context. For understanding them, you have to wait a little bit so that when we are covering the unit circle, you will understand what does it mean, okay? But for the time being, let us just concentrate on acute angles. So sine of an acute angle is defined to be semicolon equal to means defined to be equal. So let me just write, this is called the opposite divided by the hypotenuse. So and then cosine is defined to be adjacent, I will describe them of course, divided by the hypotenuse. And then finally tangent is defined to be opposite divided by the adjacent. So that is the way I shortly define it for you. So this is the way we define. Of course, it could be defined the other way around or by a little bit stranger combination, but these have proven to be useful. Other parts are also convention. Why we call this sine and this one cosine, it's just probably just a convention. Okay, for example, in this case, if I ask you sine of angle B, by the way, this SIN is abbreviation for sine. It doesn't mean anything at all. So if you just write sine, without anything in front, it's meaningless. It's just a symbol. It doesn't mean anything. Okay, so you have to put an angle in front of it. And for the time being, degrees is the only unit that we can work on. Of course, the more professional one is radians. We will study that later. But for the time being, B is an angle measured in degrees. But sine of B, as you will see, is a number. How? If you want to calculate sine of B, you go in the triangle, you go to the opposite side, which is actually this side, and then you know that there's a convention in trigonometry and geometry. If this is called capital B, the length of the side opposite to capital B is denoted by little b, and the same thing for other vertices. So if this is capital A, here the hypotenuse is little, the length of the hypotenuse is A, and this is C. So if I want to write sine of B, it is the opposite side, which is B, divided by the hypotenuse, which is A. And then if I write cosine B, it is adjacent. So if you see, this is the angle B. Of course, there are two sides adjacent to B. One of them is A, one of them is C, but A already has got the name hypotenuse. So when I say adjacent, I don't mean A, I mean C. So this becomes C over A. And then finally, tangent of B, which I have denoted by just tan B. It is opposite divided by the adjacent. So opposite is B, adjacent as I described is C. So it becomes B over C. And as you see, B is measured, is a length. It's measured in meters, for example. But the same happens for A. So I am dividing two numbers with the same dimensions. So this quantity is a dimensionless quantity. So I mean that if B is an angle measured in degrees, for example, sine of B is no longer an angle, is just a pure number because it is division of two lengths. Yes? And the same thing happens for cosine and tangent. Okay, let me just immediately to practice a little bit and write sine, cosine, and tangent for the other acute angle. So if I ask you what is sine of C, again you follow the same rule. The opposite side, which is C, divided by the hypotenuse, which is A, and then you have cosine of C. So this is your angle C. It has two sides adjacent to it. One of them is the hypotenuse, and the other one is the adjacent. So it is B over A. And tangent of C is what? Tangent of C is C over B. Yes? So this is nothing, just definition. And then already some important, very important patterns emerge here. One pattern is that you see B over A, you have it here, and you also have it here. But here it appears as sine, here it appears as cosine. So sine of B, whatever it is, it's exactly equal to cosine of C. And the other way around, sine of C also appears the same here. So sine of C is equal to cosine of B. And the other thing that you can see these two numbers are reciprocal. So reciprocal means that one of them is the other one but flipped. That's the meaning of reciprocal. So this is something that I want you to understand. It's not something to understand, it's something I want you to remember, this observation, because it's extremely important for our lesson. So if I want to write it in English words, can you help me to do that? How can I describe this part? How can I describe this part in words? This pattern that I mentioned. So what is the relation between these two angles? What is the relation between B and C? Yes, please. Yes, that's correct. But if I want to put this in English words so that we can refer to it later and remember it, So what is the relation between angle B and angle C in a right angle triangle? If I give you this is 30, you immediately tell me what is this one? 30. If this is 30, it is? It is 60, yes? Because the sum of all the angles should be 180. This is already 90. So what is the contribution coming from these together is 90. And if one of them is 30, of course the other one is 60 and the other way around. So the angle, so these two angles always add up to what? 90 degrees. There is a name for such an angle, such a pair of an angle. So these angles are called complementary. So two angles, for example, say alpha and beta, are called complementary if when I add them, it becomes 90 degrees. That's complementary, yes? This is good to know these words. In English, supplementary, the sum is what? Might be you know. Alpha plus beta is 180 degrees. So this is just a piece of terminology. I just want you to know. If two angles add up to 90, they are called complementary. One of them is called the complement of the other one. And if they add up to 180, they are called supplementary. One of them is called the supplement of the other one. Yes? So in words, if I want to write this connection in words, I would say that sine of an angle is equal to the cosine of its complement and vice versa. Okay? So this is the first remark I want to write, and I want you to remember. It's extremely important to remember these things. Okay? Sine of an angle is equal to the cosine. So I shouldn't say sine. I should say the sine. Yes, the sine of an angle is equal to the cosine of its complement. And vice versa. Yes? This is something that we actually discovered just by looking at this definition. It's not something deep. It is very ubiquitous. We need it a lot, but it is extremely simple to understand it in this context. For example, if I give you sine of 23 degrees, if you ask me, do you know the number? I would say, no, I need my calculator. But if you ask me the same question about cosine of 67 degrees, I will answer the same thing. But undoubtedly, I know that these two are equal. The reason is that 23 added to 67 is 90. So 23 and 67 are complementary. Yes? So these two angles are the same. Sorry, sine of 23 is equal to cosine of 67. Okay. One thing that I want you to know also here is this pattern that emerged here. If two angles are complementary, the tangent of one of them is the reciprocal of the other one. Or in other words, if I multiply these two tangents, B over C will be simplified by C over B, and the answer will be equal to 1. Yes?
So question, so sin 89 plus cos 1, it's all 90 then?
No. This is a different thing, you see? So you said, can you repeat it?
Sin 89 and cos 1.
Plus cos.
No, is equal to.
Yeah, yes. So I understood you wrong. Okay, if you mean this, yes.
Oh. So
yes.
They are both equal.
Exactly equal.
Because they add to 90.
Pardon?
Because they add to 90.
Yes, because 89 plus 1 is 90 degrees. So this is a pair of complementary angles. So sine of one of them is equal to the cosine of the other one. We can also write cosine of 89 is equal to what? Sine of 1. Yes, that's correct. And then I want to also, so moreover, so it is better to put this in a box. That was just an example. So moreover, the product of the tangents of complementary angles is equal to 1. Yes? That's also good to know. For example, exactly, let me use your example. For example, if you tell me what is the product, this product exactly, the answer is extremely simple. Tangent of 1 degree multiplied by tangent of 89 degrees is what? Is precisely 1. This is important, by the way. Tangent of 1 degree can be proven to be an irrational number. So if it's an irrational number, if you punch it in the calculator, you get some decimal points, but it will continue forever. That's very interesting. The same thing happens for this one. But if you multiply these two numbers, even though each one of them contain infinitely many decimal points, but the product is exactly, not approximately, exactly equal to 1. Any questions so far? So this is one pattern that is good to know. Another pattern that emerges immediately is the connection between tangent, sine, and cosine. Okay? And to be honest, if you really don't need tangent, because whenever you need sine and cosine, by a simple calculation you can find tangent, yes? And it is extremely simple to see it in this context. For example, let me divide sine b by cosine b, okay? So I divide sine b by cosine b. So then what I get, sine b is b over a, and then divided by, so sine b is b over a, this fraction line, I put it here, and cosine b is c over a. And then you know that this a and then a cancel out, and then I get b over c. But if I ask you what b over c is, you will see it's tangent of b. Yeah, so that's tangent of b. And that is also an extremely important point. Tangent of any angle, of course in this context only acute angles, but all of these formulas will actually remain the same when we actually modify the trigonometry to include other angles as well. So anyway, tangent of an angle is equal to the sine of that angle divided by cosine of that angle. So that's also good to write it somewhere here. So if I give you tangent of theta, and then what happens is that you write sine theta divided by cosine theta, yes? And then what happens, okay, let me go to another pattern. Okay, let me calculate this combination. You might wonder why. The reason is that this becomes a good number at the end if you calculate this combination. So let me take sine of b, which is a number, and then raise it to power 2, which is meaningful. So let me ask you, is this meaningful? B is that angle, but is this meaningful? No, because angle to power 2 is not meaningful, yes? What does it mean by an angle to power 2? Unless you mean the measure of the angle to power 2, then in that case it is meaningful. But whatever b is, sine of b is a pure number. And if you have a pure number, you can easily raise it to power 2 by multiplying that number by itself. So assume that you have done it for b, for sine b. You will also do it for cosine b. And then raise them to power 2, raise that to power 2, and then add these two results. Okay, so let us see what happens. Instead of sine b, I can put b over a here. So this becomes b over a, and then to power 2, and then for cosine b, you see I have c over a. So this becomes c over a to power 2, and then it becomes b squared over a squared plus c squared over a squared, but the denominators are the same. So far I reached to here. But I can continue because of the Pythagoras theorem, yes? B squared plus c squared in this triangle is equal to what? Is equal to a squared divided by a squared. But then a squared over a squared is just 1. So that is a very, very famous, probably the most famous trigonometric identity ever, that if I take an angle, calculate the sine and cosine of the same angle, it's extremely important, and then raise the results to power 2 and add them, regardless of the bigness or smallness of this angle, the answer is always exactly equal to 1. So let me also write it here. And by the way, in the books, we usually don't put pairs of brackets. There is a convention. So you see, if I want to write sine x to power 2, there is nothing wrong to write like that. But the way that the books usually write it, they write sine x and then put power 2 here. So remember, if you see this, it means this. Yes?
How did you get A2 from B2 plus C2?
No, because b2 plus c2 in this triangle, this is a right angle triangle. So b squared plus c squared is a squared by Pythagoras theorem. And then I have a squared divided by a squared, so it becomes 1. Yes? Okay, so let me write it here. So if you have sine to the power of 2 theta plus cosine to the power of 2 theta. Of course, I am reading it wrong. I sometimes read it, most of the time I read it wrong. I say sine squared theta. I should write it sine theta squared. That's the correct way. And this is exactly equal to 1. Okay. So that's also something that you can immediately discover yourself. Okay. And that is extremely important. I have seen students take square roots from both sides and then get rid of the powers of 2. Is that possible? No. Just be careful. If you just write this, so far I agree with you. That is correct. From here, you can really conclude this. But this is problematic. Square root of 1 is of course 1, nothing wrong with it. But if instead of this one you write this, then it is wrong. So this is not possible, yes? When I cross this over, I don't mean that it is not possible to find a theta that satisfies this. Yes, you can. For example, if theta is 90 degrees, cosine of 90 degrees is 0, and sine is 1. So if you add them, it becomes 1. But this is not a formula that works all the time. But what I am writing here, these are formulas that were working all the time, regardless of the value of theta. Yes? Okay, so that's also something I want you to learn. By the way, you can play around with this. For example, sometimes they might give you cosine, and then you are supposed to find sine. Okay, so if the value of cosine is put here, and then you move it to the other side, and then take the square root, you can find sine. So you can play around with these formulas. You will do some exercises later. Let us just finalize what I am going to say here. Any questions? Is that clear? Okay, one thing is that how big sine and cosine could be here. In this context, first of all, in this, I'm just talking about in this context. Can sine and cosine be negative numbers? Yes or no? Yes?
No.
Yes.
In this context. In the right angle triangle, no. Yes? Even if they cannot be 0. Can they be 0? No, because if it is, for example, if this is supposed to be 0, it means the numerator should be 0. But if the numerator is 0, I don't have the triangle in the first place. So in this context, sine and cosine are strictly positive numbers, greater than 0. But what is the highest value that sine of b can actually attain? Can it go beyond 1? Yes?
No one.
Does it reach to 1?
It can if it's 90 degrees.
No. Because I told you that in this context, B
So
is an acute angle. So in that case, no. But how did you realize it cannot go beyond 1?
Because the other side needs to have
No, because this is the opposite side, and this is the hypotenuse. And you know that in a right angle triangle, hypotenuse is always longer than the other two sides. Yes? So if you divide a number which is smaller than the other number, then the fraction becomes smaller than 1. Yes? So sine and cosine, both of them, with this kind of reasoning, are always bounded between 0 and 1 in this context. But and then when we improve that, you will see that it is possible to have negative signs and positive signs. So it means that later, I don't want to formalize it right now, but at least in this context you understand that it is not possible to be able to write sine of b equals to 2. It's not possible, yes? It should be always lower than 1, and then you see that in some extreme cases later, sine can be equal to 1, as you mentioned, sine of 90 degrees is, for example, 1. But that's also good to understand here. Okay, let me ask you one question. So what do you think the answer to this is? Sine to the power of 215 degrees plus cosine to the power of 2 and again 15 degrees. Can I say something about this combination? What is this?
1.
It's exactly 1. Do I know what the value of sine of 15 is? No, I don't have a calculator with me. So I don't know this part, I don't know this part. But what I'm sure about is the sum is exactly equal to 1. But now can you tell me what, can I say something about this? Can I say something exactly about this? What is this? Yeah? It's also equal to 1. Why is that?
Because the total sum would be 90 degrees.
Yes, because 15 degrees and 75 degrees are complementary angles. And we just learned that sine of one of them is equal to the cosine of the other one. So instead of this, what can I write? I can write cosine squared of 15, yes? So this one is equal to this one. Why is that? Because 75 plus 15 degrees is what? 90 degrees. So it means that they are complementary. So instead of this one, I wrote this using that remark up there. So I told you this is an important one. And then this becomes exactly this combination. So the answer is 1. Yes? Okay. If I ask you, what is, by the way, let me calculate something. We will talk about this a little bit later in general, but can you tell me what is tangent of 45 degrees using this idea? What is the tangent of 45? If you want to calculate tangent of 45 in this context, you have to draw a right angle triangle so that one of the angles is how much? 45, yes? And then you will tell yourself that the tangent of 45 is the opposite side. You see, opposite side divided by the adjacent. So let me call this opposite side A. What will be the length of the adjacent side in this case? If this is 45. Yes? Just say it. So if this is A, what is this length? This is 45. This is 90. It's a right angle triangle. It's 45. So how much is that? It's also 45. So this means that this length and that length should be the same because that's an isosceles triangle. Yes? The sides are equal. So this means that tangent becomes equal to A divided by this one, which is also A. So the tangent of 45 is how much? Is 1. The reason that I brought this up earlier a little bit is because I want you to solve this example for me. So let me write example. Uh, okay, so let me write it in this way. Determine. Let me give you two examples. Determine the exact value of each item. Okay, of course, no calculators, yes. So, sine squared of 10 degrees plus sine squared of 20 degrees. So let me see if we can do that. Plus sine squared 30 degrees. And then you continue this list until you reach to, of course, I can count a little bit of your knowledge before, so we'll talk about that later. Sine of 90 degrees is 1, so remember that. So I want you to calculate the exact value of this. I hope that I haven't done something wrong. And then the second one is this one. For example, let us calculate logarithm of tangent 1 degrees plus logarithm of tangent 2 degrees and plus logarithm tangent 3 degrees. And then you continue this list until you reach tangent, logarithm of tangent 89 degrees. Okay, so we want to find the exact value of this combinations without using a calculator. So, for example, tangent 1 degrees here is a number, and then you are taking logarithm of that number, it becomes a number. And you do the same thing for all these terms, and you get a bunch of numbers, you add them, and you want to calculate the result. Yes?
So,
So here, if you have forgotten, just let me write it down. We don't understand it now, but we will understand it later. Sine of 90 degrees is 1. So for this one, you need this as well.
so why can't 10 be 90?
Pardon?
Why can't 10 be 90? It can't be 90, why?
Tangent of 90 is not defined.
How? Why?
We will come back to this later. In this context, we cannot talk about tangent of 90 degrees because 90 degrees, I told you, is excluded in this context. But when we can talk about 90 degrees, we have to go to the unit circle. Then you will understand why tangent 90 is not defined. Yeah, you can think a little bit so that when I am cleaning the board, you don't waste your time. Of course, in the second one, you might remember. You have to remember a little bit about the properties of a logarithm. I can repeat them a little bit for you. But I think the first one, you should be able to do it more or less immediately.
Yeah, it wasn't that hard. But look, is it like, I remember if you can connect it to E, and isn't E like some kind of exponent?
No, you don't need to connect it to E. You need to know what is the sum of logarithms.
I don't remember, no, that's why.
No, because E, the log with E comes later. After you just, this is the normal log whose base is 10. Yes?
Yeah.
So when you say logarithm of A to the base B is equal to say M, this means that B raised to power M, it becomes A. And whenever this base B is 10, we don't write it down. And I haven't written them down, so it means that in every logarithm that you have, the base is 10. And then we had one property which is important here, is that if I have a log of x in base B plus another log of y to the base B, then we had one rule that you can write one log with the same base, but instead of adding x to y, you have to multiply x by y. So that was the only property probably that you will need here. Okay, but before going to the log one, what happens to the first one? I think it's easy, yes?
Yeah, you just pair them up, so like sin 10 degrees with sin.
Exactly. And then use that remark, yes, exactly. So the question, the first one, number one, so as you told me, I will pair them together. So I mean I will take sine squared 10. By the way, in the exam, you have to write it properly. So you put equality, and then you write it plus sine squared 80. And then the next one is what? Sine squared 20 plus sine squared 70. And then plus, you have sine squared 30 plus cosine squared 60. And then plus sine squared 40 plus sine squared 60, yes? Did I make a mistake? Yes. 40 and 50, yes. Okay, so there's one thing left, yes? 10, 20, 30, 40, 50, 60, 70, 80. So what is missing? 90, yes?
But it's already one.
But it's already one,
So
yes.
you just add.
But what is the answer to this one? Why is that one? It is not the fundamental theorem. It's because you have to explain. Because 80 and 10 are complementary. So sine is equal to sine of 80 is cosine of 10. Then I will have sine squared 10 plus cosine squared 10, which is 1. And the same story happens here, here, and there. So 1, 1, 1, 1, and this is already 1. So it becomes 5. But you have to explain. I was lazy to write it down. If you forget, you need to write some notes on your notebook, okay? Or listen to the video later. So is there any question here? Okay, so I would say that might be, this can be considered a higher level question, but you see it is extremely simple. The other one is a little bit more tricky. Do you know how to do it? So you need these properties. First of all, you need to understand what a log is. This is just a crash course on logarithm, what you need. So the meaning of logarithm, for example, when you say logarithm of 8 to the base 2, the answer is what? The answer is 3. Why is that? Because 2 to power 3 is 8. So that was the meaning of the logarithm. And it takes a little bit of work to convince yourself that the log, if the bases are the same and then you are adding, it seems that you can pull out the log sign, but the price that you have to pay is to multiply them rather than adding them. Yes? So do you want to answer that question? Yes?
Then we also pair them up here as well. So log of 10 1 and log of 10.
Okay, so let me write it
now.
now. Yes, so let me just do that.
Okay.
So number 2, what you are saying is that you can write it as log of tangent 1 degrees plus log of tangent 89 degrees.
Yes.
And then let me write one more. And then the second one will be what? Log of tangent 2 degrees plus
Log of tangent 88.
88. So I am just pairing them up. But then if I continue, okay, I just want you to understand your opinion about that. So what will be the last pair? Or by the way, how many terms are there? First of all, can you tell me, in this sum and number 2, how many terms are involved? How many terms? Pardon?
I don't know.
Okay. So,
Wait, in the first one or the second question?
now in the second question, how many terms are involved? Yes?
Is it 89?
89. Why? 1 degree, 2 degrees, 3 degrees. You go one by one, you reach to 89 degrees. How many numbers are there from 1, starting from 1 up to 89, including 89? It's 89. Yes? So this means that there are odd number of terms involved. So if I start pairing them up, one of them will be left alone. Yes? Is that clear? Which one will be left alone?
45?
45. Yes? So then it means that logarithm of tangent 45 degrees will be left alone. Okay, now can you tell me what would be the final pair?
Log of tangent 44 plus log of tangent 46 degrees.
44, yes. Tangent 44 degrees plus log of tangent 46 degrees. Okay, first of all, tell me, do you understand what I have done so far?
Yes.
So I have paired them up, and then because there are 89 terms, we realize that one term will be left alone, and that is this one. But what can I do? This one I don't have any problems with, yes, because I just told you and calculated together that what is the value of this? 1. And this is also famous. What is logarithm of 1? Is 0. Yes, why is that? Logarithm of 1, if I haven't written the base, it means logarithm of 1 in the base 10. I am claiming that this answer is 0. But this is true. Why? Because 10 to power 0 is 1. So logarithm of 1 in any acceptable base is 0. So this whole part becomes 0. This part, tangent 45 is 1. Then I am supposed to calculate logarithm of 1, which is 0. But if you go, for example, here, what can I write here? I can use this rule. I have 2 logs. They are added. So I take 1 log, but the price that I have to pay is to multiply these arguments. So it becomes tangent of 1 degrees multiplied by tangent of 89 degrees. Yes? But that's exactly one of those examples we actually did. What is the product tangent 1, tangent 89? 1. Why? Because they are complementary. Yes? And then the log of 1 is what? 0. So again, this pair of brackets is 0. I think you agree with me that this will continue until here. Yes? Because 2 degrees and 89 are complementary. And if you continue, 45 degrees and 46 degrees are also complementary. So pair by pair, everything becomes 0. 1 is left, and then coincidentally that is also 0. So what's the answer? 0. Yes. Okay, so you see that even with this very limited knowledge, you can solve actually interesting and exciting problems. Yes? Any questions? No? Okay, so let me just concentrate. So what I am supposed to talk about. Okay, one deep question actually. So there are some famous angles. I want you to remember the name of those angles without remembering all the details. Of course, be my guest if you want to. Try to use Anki. I don't know if I introduce you or not. Please make it. It's extremely important to set up your Anki today. Okay? And then you can put these formulas there. One thing I want to mention, there are some angles that are famous for us. 30 degrees, 45 degrees, and 60 degrees. These angles are famous in trigonometry not because there is something very specific about them. The reason is that we can calculate, yes?
Yeah, it's because they have an exact value.
Yes, we can calculate the exact values of sine, cosine, and tangent of them without having calculator, just based on symmetry and geometry. Okay? So this is why it is famous. And then these are tabulated in the formula sheet, but your duty is to remember the name of these angles, because if you totally forget about them, then you will not be motivated to go back and look it up. So remember the names, but you will discover what are the values. So let me start with 45 degrees. I want to calculate sine, cosine, tangent. This is part of the lesson of these three angles exactly. Okay, but let us start with the simplest one, which is 45 degrees. Why I call this the simplest one? So I want to calculate sine of 45 degrees for you. What is my starting point in this context? What is my starting point? What should I do? The first thing is to look around, yes? You need to say something.
What was the question?
The question is that I want to calculate sine, cosine, and tangent of 45 degrees.
Yes.
I have to start from somewhere.
Draw a triangle.
Okay, this is not complete, but I understand what you mean. In mathematics,
And then a 40 angle.
you need to say me, draw a right angle triangle whose one acute angle is 45 degrees. Okay? How many of those triangles are there?
1,
No.
2, 3, 4, I don't know.
So whenever you know, then you can answer. Yes? Why you answer and you say, I don't know. Yes?
I'm guessing many.
Infinitely many. Yes? And then, do you think it matters which one I pick up?
No, because
Because-
they're all the same.
No, the sizes of
No,
the
I mean,
sides are not the
value-
same.
The value when you apply them is still the same.
But at least you understand this is not trivial. Yes? This is something very deep. Yes? Because when I say the sine of 45 and I use the article there, it means it's unique. But the way that I want to construct it is not unique, because I can have infinitely many triangles. We have to somehow convince ourselves that it is independent of which triangle I am picking up, the answer will be the same. I want you to feel if you want to be good in mathematics. First of all, do you understand me? So you because you told me, take a right angle triangle whose one of the angles is 45 degrees. I agree with you. But I know that there are infinitely many triangles of those type. Yes? For example, I can imagine a line here. That is also 45 again. I can extend it a little bit. That is also the same triangle. And then if I take this one for sine, okay, these two sides are involved. Oh, sorry, not these two sides. This one and the hypotenuse. If I take this one for sine, then this side and that side are involved. Of course, it is clear that the length of this one and that one are not the same. The length of this one and that one are not the same. Okay? So it is not trivial that if I choose the smaller one and your friend chooses the bigger one, you both end up with the same number. Is that clear? Unless you have to have a good reason, yes, this is indeed the case. Okay? So why, first of all, can you tell me why all of us, independent of which one of these triangles we choose, end up with exactly the same answer? For example, if I ask you to calculate sine of 45 degrees, for example, assume that this is the triangle I choose, then I will have here A. Let me call this one B. What I write the opposite divided by the hypotenuse. For example, your friend or someone else will take the bigger triangle. Let me call this one A prime. And then that person will have to take this one as B prime. And that person calculated sine of 45 degrees to be A prime, B prime. That is completely clear. A is different from A prime. B is different from B prime. And that would be a catastrophe for me if this number turns out to be different from this number. Then it means that depending on which day of the week you are calculating sine of 45 degrees, you will end up with different answers. Yes? But this is not going to happen. Why? Why, even though A is different from A prime, B is different from B prime, but A over B is still equal to A prime over B prime? Yes, please?
Because they're proportional.
How? How do you know that?
They both have the same acute angle.
Yes, yes. So what is the Swedish word for this? Similar. They are similar. Yes, there's there's a word for it. Yes, similar. Why they are similar? If two triangles are of this property that two acute angle of one triangle, two angle of one triangle is equal to two angle of the other triangle, these two triangles are similar. This is one of the theorems in geometry in Math 2C. Okay, and this is the case because I already know that this angle is 90 and I chose this angle to be 45. So this triangle and that triangle are similar triangles. So what does it mean? It means, as you said, they are proportional. So it means the ratio of A to A prime is equal to the ratio of B to B prime. Do you agree? But A over A prime is equal to B over B prime means A over B is also equal to A prime over B prime. So that is actually extremely important. So it doesn't matter which triangle I choose, I just only need one of them. And if I only need one of them, why should I bother? I can choose the best length. And the best length is probably 1 unit. You can work with any other numbers, but I myself prefer to work with this. The simplest possible one is the one that I choose it to be 1 and this one to be 1. So you might criticize me, how do you know that the triangle should be 1? But I tell you that right now I show that it is independent of which length I am choosing. So let me choose 1 for simplicity. And this is 45, this is also 45. So let me just concentrate here. If I ask you, by the way, if this is 1 and this is 1, can you tell me how much is this one? The square root of 2. Yes, because this one to power 2 plus this one to power 2 should be equal to x to power 2. So x is the square root of 2. Yes? And then everything is okay. So sine of 45 degrees is how much? Is the opposite side, which is 1, divided by the hypotenuse, which is this one. If I ask you cosine of 45 degrees, what is the answer? What's the answer? The adjacent side divided by the hypotenuse. And if I ask you what is the tangent of 45, what's the answer? Opposite to the adjacent, which is 1. So these are the numbers for 45 degrees. By the way, when I calculated this one, I can use that famous remark, complementary angles, to conclude this. Yes? Because what is the complement of 45? 45 itself. So if sine of one of them is this, cosine of the other one is also this. So you can also immediately conclude that they have to be the same. So this is the first one that I put here. By the way, I could also reach to this conclusion by dividing this, because I told you that sine over cosine is tangent. When I divide these two numbers, it becomes 1. So if you don't mind, let me fill up this table. I will raise the board again, and then you can write it down. So let me just complete this table today, and the lesson probably will end. Okay? Okay, so my goal is to complete this table for you. So let me write theta. Here I would write 30 degrees, 45 degrees, and 60 degrees. Later we can complete this table a little bit more. And then I would write sine theta, cosine theta, and tangent theta. Today we just learned that this is 1 over a square root of 2, 1 over a square root of 2, and 1. Okay, so that is what we learned today. I want to complete the other 2 columns. But just 1 column is enough. Why? The 3rd column, I can somehow understand it using the information in the 1st column. Why is that? My question is, if I find every value for 30 degrees, then I can immediately write the numbers for 60 degrees. Why?
They are complementary.
They are complementary. I can use that rule. So remember, this rule shows up over and over. By the way, let me write something with red here. Some books, I don't know which one is written in your book. Yeah, your book written it a little bit. No, your book has written it in this way, but some books write it like this, square root of 2 over 2. I myself sometimes prefer this one. And this is also equal to square root of 2 over 2. Let us see why. Square root of 1 over a square, let me write 1 over a square root of x, any x. Of course, positive x. In this case, you can write it as 1 over a square root of x multiplied by square root of x divided by square root of x. Yes? You can multiply and divide, changing nothing. But what is the goal? The goal is to get rid of the square root sign in the denominator. Why? Because this multiplied by that becomes x, and this becomes the square root of x. So it is good to have in mind to be quick. So this is always the case if x is positive. So this is why it doesn't matter if you write 1 over a square root of 2 or you write a square root of 2 over 2. It depends which book you are using. They might differ in what. Okay, so let us just do 30 degrees as well. For 30 degrees, I have to do the same thing. I have to draw one right angle triangle so that one of the acute angles is 30 degrees. So, but that is not that trivial as before. So let me just do this like this. So let me take this one to be 30 degrees. Of course, it's not a precise picture, but hopefully you understand what's going on. And then, I don't know, one of these, I can fine-tune it. For example, I can, if you don't mind, let me just write letters here. So let me write A here, B here, and C here. I want to calculate sine of 30 degrees. Sine of 30 degrees is the opposite side divided by the hypotenuse, which is b over a. Yes? But of course I get stuck here because I don't know b, I don't know c, I don't know a. Even if you choose b to be equal to 1, which you can, but then it is not clear what a is. Then in the numerator you write 1 over a, it's not clear what is that. So you have to be a little bit creative here. So what can I do? Just remember what I am doing. I will extend this arm from this side so that this is also equal to that. So whatever this length is, I just extend it and it will probably reach here. So what can I call this length? According to my construction, I can call it b. Yes? And then I take this point and join it to this point. Yes? One question I want to ask, what do you think will be this length then? That is A. Do you agree? Why is that? Because in this way, these two triangles are congruent. Why? Because this length is common to this one and that one. And by my construction, I did the same for them. And this angle is 90, this angle is also 90. So two sides and the angle between them from one is equal to two sides and the angle between them from the other one. So these two triangles are congruent, and if they are congruent and this is A, definitely this one is also A. Is that clear? But something interesting happens here. I claim that, so first of all, if this is 30, can you tell me what this is? 60. And now we just showed that this one and that one are congruent. So if this is 60, what is this one? 60. Yes? But, so this is a triangle. On the one hand, these two arms are equal. On the other hand, this one is 60, this one is 60. So the whole thing is also 60. Yes, you know that this is also 30. So now can you tell me what is the connection between from here to here and from here to here? What type of triangle is the bigger one? Yes. So in English it is called equilateral. Yes. So it's an equilateral triangle. When it is equilateral, what does it mean? It means all the sides are of equal lengths. So this is already equal to this one, but you realize that A should be equal from here to here is how much? 2B. So A is 2B. Is that clear? So we just extended this arc and joined this point to this one. In this way, I convinced you, hopefully, that this is an equilateral triangle. If it is an equilateral triangle, means this length, which is A, should be equal to this length, which is B plus B or 2B. So A is 2B. And when A is 2B, I can rewrite this. Instead of B, I put B. Instead of A, I put 2B. Then what happens? It's 1/2. So sine of 30 degrees is 1/2. So what you write in this is 1/2. But let me again review things from you. One of these numbers I can immediately write without calculation. Which one is that? Because 30 degrees and 60 degrees, how are they related? They are complementary. So if the sine of 30 is 1/2, cosine of the other one is also 1/2. Yes? Or if you want, of course, you can calculate using this, but then you have to calculate using Pythagoras theorem. Okay, what about cosine of this one? So what should I do? In this picture, what is cosine of 60 degrees? Cosine of 60 degrees is equal to, forget about the one below, the adjacent side, which is B, divided by the hypotenuse, which is B over, oh, I calculated this one, sorry. No, what I'm doing, I'm just messing up. I have to calculate cosine of 30. So cosine of 30 is what? Is adjacent side C over A. Now this is where I want to ask you. How can I find the relation between C and A? Using this argument, hopefully I could convince you that the relation between A and B is this one. A is 2 times larger than B. But for calculating cosine, I do not need a relation between A and B as in this case. I need a relation between A and C. And apparently in this picture, the relation between A and C is not that clear. Unless you use something.
Can you use Pythagoras?
Pythagoras theorem, yes? And that is clear because Pythagoras theorem tells me a relation between A, B, and C. Okay? You want to find a connection between A and B. So, which one is disturbing you? You want to have a connection between C and A. So B is disturbing. So I have to get rid of B. If I want to get rid of B, then I come back here, I calculate B in terms of A, and then take it with me and put it here. So this becomes A squared is equal to, instead of B, it becomes A squared over 4. B squared. B is A over 2, I squared it, plus C squared. I don't like fractions, to be honest, I hate them, so I just get rid of them as quickly as possible. So I just multiply everything by 4. And then I move this to the other side, it becomes 3A squared is equal to 4C squared, and then take the square root. This becomes square root of 3, this becomes A, this becomes 2C. Okay? I think it's good, yes?
2C.
Okay, instead, so I calculate C is the square root of 3 over 2A. This is the relation between C and A. When I got this relation, I put it back here. This becomes square root of 3 over 2A divided by another A. And then this one and that one are cancelled. This becomes square root of. So the number that I put here, so what I expect you, I don't expect you to remember these numbers. They are given, but I expect you to know these numbers are famous. Okay, can you tell me this immediately?
Same.
The same number that I got here. Yes? And finally, which one do you like for calculating tangent? I can use this setup, but you already learned tangent of 30 degrees is equal to sine of 30 degrees divided by cosine of 30 degrees. Sine of 30 degrees is 1 over 2 in this table. Cosine is this. And this 2 and that 2 are cancelled, so it's 1 over square root of 3. So this number is 1 over a square root of 3. If I want to write something with red in front of it, can you tell me what to write? Yes, what should I write? What should I write?
The square root of 3 over 2.
Yes, thank you very much. Okay? And now, in your head immediately, can you know what should I write here?
Square root of 3.
The square root of 3. Why? Because I told you that complementary angles have reciprocal tangents. If the tangent of this is 1 over a square root of 3, the tangent of this is the one flipped, which is the square root of 3. So finally, we have our table. Yes? So you can sleep quite well this night because you know these formulas. Yes? We have just one thing left so that I can finish these 2 pages. One thing, yes, I want to tell you that we will complete it later, but for the time being, I want you to know how to use calculators, because most of the time I give you an angle. If I ask you use your calculator to give me this number, that is extremely easy. But of course, be careful. Calculators have 2 modes. One of them is degree mode and the other one is the radian mode. For the time being, you have to switch your calculator to degree mode. And if you want to test that, punch sine of 90 in your calculator. If it is a number not 1, it means that you are in the wrong mode. Of course, you can see on the display as well. I think a letter D should appear somewhere. It means that this is in degrees. Okay, but now we have another question. In this context, if I give you sine of theta and I tell you sine of theta is missing, and I write 2.3 and I ask you to find theta, what is your answer? How do you do that?
My answer is
What's the answer? Under 1 second. What's the answer to theta? So we are living in different reference frames, yes? Your 1 second is much longer than 1 millisecond, yes? So what is theta in 1 second, okay? In your reference frame, 1 hour. So what's that?
What was the question? I didn't listen, that's why.
So my question is sine of theta is 2.3. What is theta? Yeah.
What is theta?
I'm just asking, what is theta? Sine of theta. Theta is an angle. Sine of theta happens to be 2.3. I am asking about what the angle of theta is. How many degrees is theta?
it's very much.
I don't know.
It's like 500.
No, you should. Whenever I ask these kind of questions, because I feel that you are sleeping, the answer to this is immediately there are no such an angle, because we just learned that sine is maximally 1. So it cannot exceed 1. So how can I ask you to give the calculation in your head under 1 second? Yes, under 1 second, if you respect what I said, sine cannot exceed over 1. Yes. So sine of theta equals to 2. I am asking for this one. You should tell me this is not possible. There are no angles for which sine turns out to be 2.3. But if I ask you, what is the sine? What is the angle whose sine is 0.3? Then I don't know, but we can calculate using our calculator, and you have already done that in Math 1C. Do you remember this is the symbol that we use, and it is on your calculator. And it's a little bit unfortunate symbol. Okay, sine inverse, you need to read it in this way. So you have to switch your calculator to degree mode, and then find this button on your calculator and punch this. And then this will give you the angle, theta. And if you are in degree mode, it will give you in degree. If I give you what is the cosine of theta is equal to what I say, for example 0.4, if I ask you to find theta, what do? You have another button on your calculator, so you write cosine inverse of 0.4. And if I ask you about, by the way, let me ask you about this. What is tangent of 3 theta is equal to 5? Yes, can I calculate this? Yeah, here we can, because there are no limitations for tangent. So tangent can be extremely high number. So this means that you need to write 3 theta is tangent inverse of 5. But I am not looking for 3 theta, I am looking for theta, so I have to divide everything by 3. So this becomes whatever the calculator gives me, divided by. But of course, this is a little bit not complete. In this context, it is complete. When theta is an acute angle. But later, we spent actually 2 or 3 sessions talking about these things, which is trigonometric equations. Unfortunately, life is not simple as this one always. So you have to solve it later. You have already probably studied Math 3C, but don't worry about that. I will start again from scratch if you have forgotten something. Anything else that I need to do here? Okay, one thing that I just want to mention, this is, I told you, it's a little bit unfortunate symbol. Because I just told you what is the meaning of this, do you remember? I told you that when you see this symbol, it means sine x to power 2, yes? Now I am doing the same thing, but instead of 2, I am putting -1. You might expect that this is also should be interpreted in that way. And if you interpret it as a power, then you might write 1 over sine over x, which is also true if you interpret this as a power. But unfortunately, sine inverse, you should interpret it differently from this. And this is why some books, instead of writing sine inverse, they use arc sine. In that case, that is good, because there is no matter of confusion between these two. But anyway, the book is using this symbol, but extremely important. Do not interpret it as 1 over sin. Okay? Whenever you see this symbol, it's always meaning. And then, by the way, how do you read it? You read it sine inverse of 0.3, cosine inverse of 0.4, and then tangent inverse of 5 divided by 3. And that's end of the story. Any questions? There's 10 minutes left. If you don't have any questions, we can finish the lesson. But I will update the Google Classroom. I really want you. So next time, next time I can really give you time to practice. Okay? And then the solution manual is uploaded, and then the faucet is also at the end. Please, whenever you solve a problem, consult the solution manual as well.